Welcome back दोस्तों. Let us now deal with next concept of straight line, which is angle between two intersecting lines. So suppose we have two lines. This is line number 1 having some slope, let us say m1, and this is line number 2 having slope m2. And suppose the angle between two lines is theta. So the formula for angle between two intersecting lines is given by tan theta is equal to mod of m1 minus m2 upon 1 plus m1 m2. Here theta is the angle between two lines. M1 is slope of line 1, M2 is slope of line 2. So let us derive this formula. So let us now look at the derivation. So let us say we have two lines. This is, let us say, line 1 making some angle beta with positive x-axis. This is line, let us say, 1. And let us suppose we have another line, let us say line 2 making some angle alpha with the positive x-axis. So the angle between line 1, which is this line, and line 2, which is this line, is, let us say, theta. Now in this triangle, if you see this triangle carefully, if I apply exterior angle theorem, so let me apply exterior angle theorem. So exterior angle theorem states that the exterior angle, in this case beta, is equal to the sum of remote interior angles, which is in this case alpha and theta. So exterior angle beta will be alpha plus theta. So beta is alpha plus theta. From this we get theta. It comes out to be beta minus alpha. So theta is beta minus alpha. Now taking tan on both sides, we get tan of theta is tan of beta minus alpha. So tan theta is tan of beta minus alpha. Let us use the identity tan of A minus B. So in trigonometry, we have learned tan of A minus B is nothing but tan A minus tan B upon 1 plus tan A into tan B. So this is the trigonometric identity which we want to apply. So tan of beta minus alpha will become tan of beta minus alpha. This equals tan of beta minus tan of alpha upon 1 plus tan beta tan alpha. So let us use this identity in this equation. Tan theta is tan of beta minus alpha. So tan of theta is tan of beta minus alpha, which we found as tan beta minus tan alpha upon 1 plus tan beta tan alpha. So this will come out to be tan beta minus tan alpha upon 1 plus tan beta tan alpha. So from this I can say tan theta is equal to tan of beta minus tan of alpha upon 1 plus tan beta tan alpha. Now if you see, this is line 1 making angle beta. So I can say slope of line 1 m1 is nothing but tan beta, because we have already studied slope is tan theta, where theta is the angle made by the line with positive x-axis. This line 1, it makes angle beta with positive x-axis. So slope of line 1, which is m1, is tan beta. Similarly, slope of line 2 is equal to tan alpha, because line 2 makes angle alpha with positive x-axis. So let us substitute tan beta as m1 and tan alpha as m2 in this equation. So tan theta will become tan beta, which is nothing but m1, minus tan alpha, which is nothing but m2, upon 1 plus tan beta, which is nothing but m1, and tan alpha, which is m2. So our formula, we get tan theta is m1 minus m2 upon 1 plus m1 m2. Now we put a mod sign here, which is because this theta angle can be obtuse or acute. If theta is acute, then this tan theta will come out to be positive, and if theta is obtuse, then it will come out to be negative. So from this formula, we will always get the acute angle if I put mod sign here. So mod sign means, in this case, this quantity on the right hand side will always be positive. That means this theta will be acute angle. So from this formula, we get theta as the acute angle between two lines. If I want to find the obtuse angle, it will be nothing but 180 minus theta. So from this formula, I will get the acute angle between the two lines. So that is what is the use of this formula. Tan theta is mod of m1 minus m2 upon 1 plus m1 m2. Now let us see some special cases. So the first special case which we'll see, if the two lines are perpendicular. So suppose if line 1 is perpendicular to line 2. So in that case, the angle between two lines, theta, it will come out to be 90 degree. So our equation will reduce to tan of theta, which is 90, is m1 minus m2 upon 1 plus m1 m2. Now tan 90, we know it is sin 90 upon cos 90. Sin 90 is 1, cos 90 will be 0. Because tan 90 is sin 90, which is 1, upon cos 90, which is 0. So from this, if I equate the denominators, then I will get 1 plus m1 m2 is equal to 0. So from this, I can say product of slopes m1 m2 is minus 1. This is if the two lines are perpendicular. That means the angle between them is 90 degree. So this is an important result. If the product of slopes is minus 1, then the two lines are perpendicular to each other. So this is one result which we have to remember. This formula also is important. Tan theta is mod of m1 minus m2 upon 1 plus m1 m2. This result also we have to remember. And let us now take special case of parallel lines. So suppose if the two lines are parallel. So if line 1 is parallel to line 2, then we know the angle between two lines will be 0 degree, because parallel lines make no angle with each other. So that means the angle is 0. So let us substitute theta as 0. So tan 0 is m1 minus m2 upon 1 plus m1 m2. Now tan 0 is sin 0, which is 0, upon cos 0, which is 1. So 0 upon 1 is 0. So I can say the numerator will be 0. So m1 minus m2 is 0, which gives m1 is equal to m2. So if the slopes of two lines are equal, then we can say the angle between two lines is 0 degree and the two lines are parallel lines. So from this we have to remember three results. One is the acute angle between two lines is given as mod of m1 minus m2 upon 1 plus m1 m2, where m1 is slope of line 1, m2 is slope of line 2. Second result, if the two lines are perpendicular to each other, that means the angle is 90 degree, then the product of slopes m1 m2 is minus 1. This is for two lines which are perpendicular. And if the two lines are parallel to each other, then in that case the slopes of two lines are equal. M1 is equal to M2. So these three results we have to remember from this concept, and we will move